And this tiny tooth holds a massive prehistoric secret. And the late Cretaceous landscape hides giants and their smallest kin. And for decades, one creature has defied clear classification. The Tyrannosaurus rex dominated, but what about its smaller cousins? Meet Nanotyrannus, smaller, faster, and incredibly contentious. Is this a distinct species, or just a juvenile giant? Its proposed size suggests a niche predator, distinct from adults. The first specimen sparked immediate, passionate disagreement among experts. The primary argument hinges on growth patterns and bone histology. Bone histology, slicing thin sections, reveals the creature's true age. Features like the skull shape suggest maturity, not youth. The femur structure lacks the characteristic features of a young T-Rex. If it is a juvenile, it grew far slower than expected. Growth models for T-Rex simply do not accommodate this morphology. Its tiny arms appear more functional, less vestigial than T-Rex. Now that we understand the morphological conflict, let's explore the naming issue. Taxonomy demands clear, distinguishing features to separate species. But early descriptions were fragmented, lacking the complete specimens we see today. And the discovery of more complete skeletons provided crucial comparative data. And the length of the snout relative to the eye socket is key. If it is a juvenile, it exhibits extreme paedomorphosis. A paedomorphosis means retaining juvenile traits into adulthood. But the overall skeletal structure argues for a separate genus. Even subtle dermal impressions sometimes hint at species difference. Comparing it to other small tyrannosaurs offers context for its uniqueness. The pelvic girdle proportions strongly deviate from known T-Rex juveniles. If Nanotyrannus existed, it occupied a crucial ecological niche. It would have hunted smaller prey, avoiding direct competition. The debate touches upon the very definition of a species boundary. A modern technology allows for objective, non-invasive comparison methods. Statistical clustering often separates these specimens into distinct groups. Juvenile T-Rexes show rapid frontal bone fusion later in life. Nanotyrannus seems to lack this expected fusion pattern entirely. If fossil preservation biases, what evidence we actually recover? The robust jaw muscles suggest a specialized diet, not generalized youth. But tooth replacement rates also provide insight into lifespan and maturation. These teeth show wear patterns inconsistent with a rapidly growing juvenile. The environmental pressures of the maastrichtian stage were immense. In a juvenile T. rex would likely shadow its mother for years. The foot structure of Nanotyrannus suggests a different locomotor strategy. Conflicting interpretations continue to fuel this fascinating scientific divide. Each new discovery forces a re-evaluation of the entire Tyrannosaur lineage. And even braincase morphology suggests a unique sensory profile. Boar, if it's a true species, it represents evolutionary experimentation. And the lack of transitional fossils leaves the question permanently open. But we rely on morphology because molecular data remains inaccessible. The tail's stiffness differs significantly from the expected T. rex flexibility. But these subtle biomechanical shifts suggest an independent evolutionary path. Or perhaps, this is a striking case of convergent evolution. But the lack of definitive growth indicators remains the central problem. At the giant T. rex dominated the apex predator role completely. The smaller form indicates a vastly different metabolic requirement, too. The geological record holds the final answers, buried deeper within. Pathologies could mimic features of a distinct species, complicating readings. Ultimately, this debate showcases science in motion, refining knowledge constantly. The protagonist in this story is rigorous, persistent scientific inquiry itself. But will Nanotyrannus remain a juvenile, or become its own tiny titan? The evidence leans toward a distinct species by many modern metrics. This small predator reminds us how much we still do not know. But the question of Nanotyrannus awaits the next groundbreaking fossil discovery.